So this is controlling a CPU cooling system with a control system. The goal of the system is to basically maintain the temperature at a safe temperature for the system. And this is done by the temperature increasing by the power input of the CPU and the power consumed. It is controlled using the fan speeds that push the air through the cooler. The software and hardware configuration is basically just the computer cooler, like the heat sink and the CPU fan mounted on it. And the software is modeled in Simulink using Simscape's Fluids Toolbox. The system is mainly controlled by a fan controller subsystem, which is three-speed switch that changes with temperature, and those three speeds are represented by relays that add up. And as you can see, these are the three relays down here in the subsystem, and they basically represent each level of speed, and they are activated based off of the change in temperature, which is 2.5 degrees Celsius. And the first one is turned off when it goes below 2.5 degrees Celsius, and then turned on when it goes to that changes in 2.5. The next one is 2 times 2.5, it turns off. 2 times 2.5 plus 1, it turns on, and so on. And the fan speeds are 2,000, 2,500, and 3,000 RPM. The green block is the ideal angular velocity source, where the port S is a signal port, and the port R and C are mechanical rotational conserving points. The system modeling, um, the cooling system can be modeled by using an input of power consumption of the CPU over time. This also can be used in a heat transfer system to find the relationship between the air blowing over the fins of the cooler and the temperature of the CPU. Some factors that could be factored into the system are air temperature and dimensions of the computer. Continuous discrete math, it's mostly trial and error for the speeds of the fans. And some nonlinear concerns are the relationship between the nonlinear fan speed and the nonlinear power consumption. The system is dependent also on the specific components that are used within it. This is the main Simulink system. This is the first part where the inlet, case drill, and gas properties, and also the solver configuration is. Solver configuration basically allows the simulation to be run. The gas properties declares like the properties of the gas, in this case air. The case grill is where the pressure drop occurs within the computer, and the inlet is where the air comes in. This is the heat transfer subsystem. And so as you can see, there's a heat dissipation source, which is basically just an ideal energy source with an input of the heat profile. And then there's also the CPU sink basin fins blocks, which are the thermal masses represented there. And then there's the conduction blocks that represent the conductive heat transfer between each mass, I guess, or like component of the cooler. And then there's also the temperature sensor down there, which allows the temperature to be read and has a reference of absolute zero. And then that's fed into a relay, which is then fed into a temperature to go block, which basically is like delay allows it to be like a data point to be plotted every second. This is a heat profile, which was the data was collected from Minecraft using a sample every minute for 15 minutes and it was read using Omen Gaming Hub. This is the last part of the system, and it's basically the airflow sensor environment, CPU fan control, as previously mentioned, target temperature, the TCPU from block, and the CPU temperature on the scope. The airflow sensor collects things like thermodynamic and temperature and pressure sensor or pressure data. And CPU fan basically just accounts for the fan parameters. And then the environment is sets the boundary conditions for the gas. TCPU is basically connects the data from the previously mentioned to go box to the from box in here, and then allows it to be plotted and looped back into the system. The sum block allows for the loop. This is the temperature curve of the system outcome from the power. Some troubleshooting is that this model can be adjusted for a different computer. There are not really any risks to do with this because it's a very simple system. And then the only concern is you can't overload the system with excessive power. These are my references. And then something that was kind of cool within this model is it has SCC Explorer, which basically allows you to go more in depth. So like if I wanted to see the airflow sensor data, I could go in here and see the pressure and temperature sensors. So this is the temperature within the airflow sensor, and then here's like the density within it. And I can also go in here and find the temperature of the CPU. And just there's a ton of stuff in here that's collected.